1, find the value of a mysterious function closest to target. So for this problem, we are given a function, and this function is just the OR operation, the bitwise OR operation. As we can see, the first number is array L, and if the R is less than L, we're gonna return something negative value. It's gonna be really big. Otherwise, the answer is gonna be the first value inside the array. It's gonna be array L, and then we're gonna continue L plus 1 until R is also inclusive. So this L and R is inclusive. So we're gonna just check the bitwise AND operation, and we're gonna return the final answer. So this is what we are doing. Now let's just continue to read the problem. So Winston was given just a name, was given the above mysterious function. He has an integer array and an integer target, and he was to find the values L and R that mixes the value with this function call. So this function call is basically the bitwise OR operation from L to R. Minus target is going to be the minimum possible. So we're going to just return this minimum possible value. So let's just check the constraints. So the length is going to be 10 to the power 5, and the target is going to be 10 to the power 7, and the array is going to be 10 to the power 6. So this means we cannot solve the problem by using O(n) square. And let's just check the first example. So we're going to call the function with all the pairs like 0, 0, 1, 1. Definitely it's all the pairs. So Winston got the following results. So this is all the possible results, and the value closest to 5 is 7. So 7 minus 5 is going to be 2. So we're going to return 2. So this is what we are doing. So the first idea is that we might want to solve it by using the brute force. So let's just try to solve it by using the brute force. So for j in range I to n, and the result gonna be the minimum of the result and absolute value. It's gonna be some value. It's gonna be this. We're gonna use a reduce. And this is just to explain the problem. At least we need to understand what is the meaning of the problem, right? So it's gonna be the add operation. So what is add? I think the add operation is gonna be like this. We're gonna basically we cannot put something inside a reduce with this sign. We have to use this add with underscore, and the array gonna be I to j plus 1. So minus k. Finally, we're gonna return this result, and let's just set this result to infinity from the beginning. Now let me just run it. This is gonna be length of the array. And what is the k? It is not k, it is target. Let me just use the target. As you can see, at least it works, but it cannot pass for all testing cases because this is n-cubic. So definitely we can reduce the time complexity to O(n) square, but it didn't work. We have to reduce it to something like n log k, n log u. As you can see, it didn't work. It is a time limit exceeded. Because this is n-cubic, definitely it didn't work. We should solve it by using n log u, and this u gonna be 10 to the power 7. It's gonna be the value of the array I. I don't know, it is array I 10 to the power 6 or 10 to the power 7, doesn't matter. So this is exactly what we are doing. But how can we reduce the time complexity? We're gonna use the LogTrick. The LogTrick is used to reduce the time complexity from O(n) square to n log u. So we will not use those lines, and we're gonna set a variable j. So j gonna be I minus 1, and we're gonna check this j while j is more than or equal to 0, and nums j. Here we're gonna use add nums I. If it is not equal to nums j, if it is not equal to nums j, we're gonna update the nums j. So nums j gonna add equal to nums I. And from here, we're gonna use j minus 1. Yeah, but in between we're gonna update the value of the result. It's gonna be the absolute of nums j minus k. Yeah, but if it is a single number, for example, it is a nums I, we have to calculate it. Yeah, so from here, let's just update the value from the beginning. So for here, we still need to update it. So this one going to be nums I minus nums k. Yeah, so this is going to be the solution for the problem. Maybe you don't understand. Let me just explain. So just imagine we have something like let's just check the first example. We have some numbers. Yeah, this is 5 numbers. I'm gonna just use 4 numbers to represent it. So what if we just have 4 numbers? We have A, B, C, D. Yeah, A, B, C, D just means 4 numbers. It can be some random number. It can be any numbers. Yeah. So for our calculation, normally we're gonna use 2 for loops to calculate it. Yeah. So for the algorithm, so this is A. And what about the second loop? For this A, we've already calculated it's going to be absolute of the nums I. It's going to be A minus K. Yeah, for a single number, we calculated. But what about some with 2 numbers or 3 numbers? How can we calculate it? Yeah, so this means for the second loop. So for the first one, this is A. This is okay. This is A. This is okay. What about the second loop? For the second loop, we're going to have this is B. We're going to keep it there. And here we have the add operation. This is A add B. Yeah. And third, this is C. This is going to be B add C. So for here, it's going to be A add B add C. Yeah. So what about here? It's going to be D. This one going to be C add D. And this going to be B add C add D. Yeah. So this one here is going to be A add B add C add D. Yeah. So why are we going to do it like that? Because this is like 2 for loops. If we did solve it, actually it's going to be O(n) squared. But we can stop it like that because we do not need to calculate all the possible cases. Yeah. So now let's just imagine, what if this is C equals to C add D? Is that possible? So currently we will not check if it is possible or not. So let's just imagine, if from some calculation, from some point, from some positions, this is possible. So this means C add D gonna equal to C. Yeah, so after the calculation, if C add D, let me just use an example. Maybe, yeah, maybe C is 0, 1, D is 1, 1. Yeah, so this is D. Our new numbers from nums I. It is 1, 1, it is 3, and C is 0, 1. So C and D gonna equal to 0, 1, because this is a bitwise add operation. Yeah, C and D gonna equal to 0, 1. It's gonna equal to C. Yeah, so this means after the add calculation, the numbers are gonna become smaller and smaller. And if we turn the binary number into a set, so the set is gonna become smaller and smaller. Yeah, if C and D equal to C, basically this means C is a subset of D. Yeah, so this is really important for us to understand the problem. So if C is a subset of D, this means B, C, D, B and C and D gonna be a subset of D as well. Yeah, because C is a subset of D, any number B and C gonna be a subset of C, and C is a subset of D. So this means B and C gonna be a subset of D, and A, B, C, D gonna be a subset of D. Yeah. So if this is equal, if this is D, C is a if this is C is a subset of D, and BC gonna be a subset of D. This is a C and D. If this is C and D, if this is C and D are equal to C, so this is a C and D. Yeah, C and D gonna equal to C. Let's just try to change that, because this is C and D gonna equal to C. Let's just put it here. So this gonna be B and C, because C and D equal to C. Yeah. So here we're gonna continue to change that, because C and D gonna equal to C. Yeah. So here gonna be A and B and C. Yeah, because for some calculations, that's just imagine if C and D equal to C. Yeah. If it is equal, what's gonna happen is that here, if we continue to calculate it, it's going to be something like B and C. This one going to be A and B and C. Yeah, this is going to be exactly the same, because B and C here, B and C here, A and B and C here, A and B and C here. This means normally we do not need to calculate it anymore, because it's exactly the same. Yeah, because from the previous calculations, like from here, 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 definitely this is not equal, and we stored all the value and we calculated it before. Now, for the next loop, do we need to calculate it? No, we do not. Because it is equal, we do not need to calculate it. Yeah, because if C equal to C and D, so this means C gonna be, yeah, this means C gonna be a subset of D. Yeah, so this means we do not need to calculate. This is D and this is C. Yeah, this means we do not need to calculate it. But how many such calculations? Is that like 10 to the power 5, or is that only 30 such kind of calculations? If we need to calculate, at most they're going to be 30. Why? Let's just use an example. So for any binary number, so from the beginning, maybe we have such kind of binary numbers. Yeah. So we have some binary numbers. It's going to be like this, and then we're going to do the add operation. So this is going to be nums I. Yeah, so this is going to be num I here. Let's see, this is going to be nums j, and then we're going to use the nums I XOR with this number. Yeah, maybe nums I is something like 0 0 0 1 1 1. What is the calculation after that? After that, it's going to be something like this. Yeah, because it is the bitwise add operation. It's going to be 0 0 0 1 1 1 1. Yeah. Now, what about the next number? If the next number is something like yeah, if the next number is something like 0 0 0 0 0 and 0 0, so what's going to be the final result? So the final result is going to be this one. Yeah, because this is a bitwise add operation, it's going to be 0. So what happens is that, what about the next number? If it is something 1 1 1 here, it doesn't matter, because after the add operation, this one add this one, it's going to still be this number. Yeah, it will not change, it will still be 0. Yeah, so this means definitely there are going to be less calculations than we expected. It's going to be at most maybe 30 calculations. Yeah, because for such number, we have so many ones. If it is exactly the same, this means they are equal, we're going to stop it. But if we were to reduce it and we were to calculate the maximum possibilities, maybe we're going to reduce one by one. So for the first time, it's going to be something like this, and the second time, it's going to be something like 2 zeros, and then we have 3 zeros, and we have more zeros. So in total, it's going to be 30 such kind of calculations. Yeah. Otherwise, if it is less than 30, it's going to stop. Yeah. So this is why we're going to use the LogTrick to solve the problem. Let me just run it. So this is the nums I. Let me use array. So let me just change it to array and run it. This is not okay. It's going to be a target. Yeah, now as you can see, it works. Now let me just submit it. Yeah, if we can pass, definitely it means it's going to be the time complexity going to be n log u instead of O n square, because for this kind of calculation, at most there are going to be like 30 calculations. it depended on this number, array I. It's going to be 10 to the power 6, maybe 20 calculations, but definitely it is not 10 to the power 5. That is why it works. Yeah, I think that's all about it. Thanks for watching. See you next time.